There are two different type of coordinate systems into the ETABS software. One is local axis coordinate system, another is global axis coordinate system. Suppose this is a beam. This is the CG point of this beam. This is one axis. This is another axis, and this is another axis. So this axis we can call it as axis 1. This axis we can call it as axis 3, and this axis is axis 2. The forces along the axis 1 is F11. Forces along the axis 3 is F33. Forces along the axis 2 is F22. Now the moments about the axis 1 is M11. Moments about axis 2 is M22, and the moment about axis 3 is M33. Now this scenario is for the line element. So there are two different type of elements are there into the ETABS. One is line element, another is area elements. So for line element, this type of local axis arrangements are there. So the forces along particular local axis, and the moments are about that particular local axis. So this M11 moments we can call it as torsional moment or torsion in short. This M22 moment is minor bending moment, and this M33 moment is major bending moment. Same way, this F11 force is the axial force. This F33 force is the minor shear, and this F22 is the major shear. Now this is the local axis arrangement for line element. There are another type of axis system are there into the ETABS, that we can call it as global axis coordinate system. So in the global axis coordinate system, this is X, this is Y axis, and this is the Z axis. So Z axis we know it is the vertical direction, and this X axis and Y axis are the horizontal plane. This is the vertical plane. This vertical plane means along the gravity. This is the gravity direction. So this is called as global axis coordinate system. Now, what type of structural elements are fall under the category of line element? Suppose columns, beams, braces. These falls under the category of line element. And there are another type of element system are there, which we can call it as the area element. slabs, shear wall, rams, these falls under the category of area element. So for local axis, there are three different colors are there. One is red, another is green, and another is blue. Red is always one axis, green is always two axis, and blue is always three axis. So the bending moment bending moment about one axis is M11, we can call it as torsion. Bending moment about two axis, that is M22, we can call it as minor bending moment. And bending moment about three axis, we can call it as M33, that is the major bending moment. Same way, the forces along the one axis is F11, that is the axial force. Forces along the two axis, that is F22, which is major shear force, and the forces along the three axis, that is F33, which are the minor shear force. Now for area element, suppose this is the area element, this is a slab, this is a shear wall. So for slab, this is the one axis, this is the two axis, this is the three axis. Same way for shear wall also, this is the one axis, this is the two axis, this is the three axis. So one axis, this is slab, this is shear wall. The green is the two axis for slab, this is the two axis for shear wall, and the blue one is the three axis for slab. Here also three axis for shear wall. In this way, the local axis coordinate system arrangement can be done into the ETABS software. Now here this F11, F22, F12, these are the in plane forces. For area element, these forces are along the particular local axis. Local axis. Now this M11, M22, M12, this is the out of plane moments, bending moment, these are also along the particular local axis. S11, S22, S12, these are the stresses. Stresses means force per area. Along particular local axis. S13, S23, punching shear stress, V13, V23 punching shear force. 1-3 means in 1 and 3 plane, 2-3 means in 2-3 plane, V13 means 1 and 3 plane, V23 means 2 and 3 plane. V13 means in this plane, V13. So this is the plane, this is the 1-3 plane. So the forces along this plane is the punching shear force, V13. Now if we go to the ETABS, for viewing the local axis, we need to go to the set display option, object assignments, and we need to check the boxes of local axis under frame assignments and the shell assignments. And click on apply. Okay. So here you can see this is the beam. So here it is the beam, and this is the beam. So the local axis system, this is the red one, means this is the 1 axis, this is the green, that is 2 axis, and this is the blue, that is 3 axis. So the bending moment about this axis, that is the major bending moment, and the forces along the 1 axis is the axial forces, and the forces along the 2 axis is the shear forces, major shear force, major shear. Same way for column also. This is the 1 axis, 2 axis, and 3 axis. RGB. Now if I select the slab, this you can see, this is the axis 1, axis 2, and axis 3. So one is the red one, red is the axis 1, green is the axis 2, and blue is the axis 3. So here in this plane, that is the 1-3 plane, these forces are the punching shear forces. Same way 2-3 also, punching shear forces and punching shear stresses are act along this plane, in this plane. Now for shear wall, if we select the shear wall, this is the axis system of shear wall, local axis system. This R is the 1, green is the 2 axis, and blue is the 3 axis. If we draw suppose I am drawing a slab here, I'm drawing a slab here. With different orientation. So in all the cases, local axis arrangement system for slabs are following the same pattern, that is R G B, R G B, 1 2, and in this vertical plane this 3. For all type of slabs for with different shapes, different orientations, different direction, the local axis pattern of the slabs are same. This pattern follow the global axis pattern in the ETABS. So you can see, if we zoom it here, this is the global axis pattern. This is X direction, this is Y direction, and in the vertical this is Z direction. So this pattern has been followed by the slabs for local axis arrangement. Same. If we draw the shear wall, shear wall follow different pattern. One thing we need to notice here, that is the one axis is always along the length of the shear wall. This one axis, that is the red axis, this one axis is always following the length of the shear wall, always following the length. Now I am running this analysis. After running the analysis, here we can go to check the bending moment and the axial forces of the line elements. So here we can see that for line element, this axial force, this is F11, the shear force is F22, the shear 33, that is F33, this torsion is M11, this is M22, this is M33. These are the in plane forces and out of plane moments for the line elements. We can check from here. Same way, if we go to the shell stresses, here you can see this F11, F22, F12, M11, M22, M12, V13, V23. These are the in plane forces. These are the out of plane moments. These are the shear forces. If we go to the shell stresses, here also S11, S22, S12, S13, S23, that is the stresses. These are the punching shear stresses. So from here we can find out the different values of stresses or moments, or for axial forces. All these things we can find out from here. So this way local axis arrangement system works into the ETABS software.